And today we're going to discuss the chapter Introduction to Trigonometry. So before starting our chapter, we need some basics, okay, that are very essential to continue or to move on to our chapter called Introduction to Trigonometry. Many of you might be afraid of trigonometry, but I assure you that if you are going to listen to this 1 hour session, this chapter will be easy for you. So without any delay, we are going to start our chapter trigonometry. So first of all, I'm going to ask you about triangles. So everybody know about triangles. You have learned so many properties related to triangle, different types of triangle, right? So I hope I am audible to everyone. Am I audible to everyone? Okay, let's continue. So, you know about right angle triangle, right? So, what is the peculiarity of right angle triangle? What is that peculiarity? One angle of right angle triangle will be always 90 degree. That is the peculiarity of a right angle triangle. And we also have learned an important theorem related to this right angle triangle. What was that? Yes, it is Pythagoras theorem. Pythagoras theorem, we studied it with respect to right angle triangle, right? So what was this Pythagoras theorem? What was that? So if you consider a right angle triangle, so I am drawing a right angle triangle here. So what is the peculiarity? One angle is 90 degree, right? One angle will always be 90 degree. So a right angle triangle will have a hypotenuse. What is this hypotenuse? Hypotenuse is the longest side of the triangle, right? Longest side is known as, so this is the longest side. So this is the hypotenuse. Okay, that one is the hypotenuse and this one is the base and this one is the height, or what it is other name? Height or altitude, right? Base, height and hypotenuse. So this Pythagoras theorem connects all these three, right? Base, height and hypotenuse of a right angle triangle. What was that? It is nothing but base square plus height square or altitude square will give you the hypotenuse square, right? It will give you the hypotenuse square. This is the Pythagoras theorem. So if I name this triangle, if I name this triangle as ABC. So this is right angle triangle ABC. How can you rewrite this equation? We can write this as, since base is BC, right? BC square plus AB square. Height is AB. AB square, that is equal to AC square. Is that clear to you? This is Pythagoras theorem. I'm just revising or recalling it. Okay, so if you are given any two sides of a right angle triangle, we can find the third side by using this theorem, right? If you are given the base and height, then you can find the hypotenuse. Using this equation, we can find out the hypotenuse. Similarly, if you are given hypotenuse and base, you can find the height also, right? Is that right? Now, I'm going to take you to situations that happens in our surroundings where we can imagine a right angle. Okay, there are situations in our that is in real life examples, like we can form a right angle in that particular situation. I'll explain it with the figure. So consider the first figure. Okay, this one is the Qutb Minar, and a person is standing here and he is observing the top of that minar. Okay, he is observing the top of the minar. He is ground. Okay, so he wants to find out the height of the minar. He wants to find out the height of the minar, but he only knows this particular distance. That is the distance from where he stands to the bottom of the minar. He knows that distance, but he doesn't know any other thing. You can imagine a right triangle here, like this. Okay, consider that minar as the height and the distance between that person and minar as the base, and then the line of sight, this one, the line of sight that he looks up to the minar can be considered as the hypotenuse. So clearly you can see a right angle in that figure. Okay, so here this person only knows this distance. Okay, which distance is known? Only this distance is known. He has to find out the height of the minar. Will he be able to find out it using the Pythagoras theorem? Using Pythagoras theorem, if two sides are known, we can find the other side. Without measuring, he cannot find out the height of the minar, right? Only he knows one distance, right? Now consider another situation that is given in second figure. Okay, you can see the second figure. Here also you can imagine a right angle triangle to be formed, right? A person is sitting on the top. You can see that on the top of that balcony, a person is sitting. And this is a river. And the other bank, in the other bank of the river, you can see a temple. And here it is a flower pot. Okay. So the person sitting on the top is observing the flower pot. He is observing the flower pot. Okay. And he wants to know the width of this particular river. He wants to know the width of the particular river. Here you can see a right angle triangle is formed, right? This can be considered as base, this height, this can be considered as a height, and the line of sight can be considered as the hypotenuse. So a right angle triangle is formed. Here we have to find out the width. He knows the distance, like this distance, that is the height. The height at which he is sitting, he knows that distance, but he wants to know the width of the river. Will he be able to find out it using Pythagoras theorem? Because this distance is missing, right? We cannot measure this distance. So Pythagoras theorem cannot be applied to solve these particular type of situations. So is there any other mathematical technique that can be applied to solve these problems? That is called as trigonometry. Okay, this type of problems can be solved by using trigonometry. Trigonometry is nothing but it is a branch of mathematics that deals with the sides of triangle. That is, you can see here, trigonometry can be split into three Greek words. Okay, it is trigon and metron. Trigonometry can be split into three Greek words, that is trigon and metron. Tri means nothing but three, gon means sides, and metron is measure. So we can say that in simple way we can say that it is just it is the study of relationship between the sides and angles of a triangle. Trigonometry is the study of relationship between the sides and angles of a triangle. So this using this trigonometry we can solve the problems that we mentioned earlier. Okay, so we are going to start trigonometry. We have defined what is trigonometry, and this trigonometry was in earlier times it was used to find out the distances from our earth to stars as well as other planets, etc. Nowadays it is widely used in different fields like engineering, physical sciences, in every walks of life. It is not directly, we cannot see the application, but all the methods that are used in these fields applies the concepts of trigonometry. Okay, so that's it. So in this chapter, we'll be dealing with trigonometric ratios that we'll study. Trigonometric ratios, then trigonometric ratios of specific angles, and then we also study trigonometric identities. I'm sure that you will be familiar with algebraic identities. Similarly, we also have identities related to trigonometry that is called as trigonometric identities. Okay, so let's just start our chapter. Trigonometry. Okay, so first of all, consider a right angle triangle. Consider a right angle triangle. So one angle will be 90 degree, right? So I'm going to name this triangle as ABC. Okay. So this is right angle triangle ABC. Now we know the name of AC, right? It is nothing but hypotenuse. It is the hypotenuse of this triangle. AC is the hypotenuse of the triangle. Now we are going to define this AB and BC, that is the perpendicular sides AB and BC in terms of angle A. That is, we are going to connect angle A and the sides. Okay. That is, this can be, this is actually angle CAB or it can be PAC, right? We name angles in that way, but here there is no any other angle in that particular position. So we can briefly say it as angle A itself. So I'm calling it angle A. Okay, I'm calling it angle A. If you want to give a specific or particular name for that angle, you can call it theta also. So here I'm just calling it angle A. Okay, so consider angle A. Consider angle A. What can you say about the side BC? The side BC with respect to angle A. What can you say about BC with respect to angle A? BC is the opposite of angle A, right? BC is the side opposite to angle A, right? So I'm going to write this as opposite side of angle A. Okay, opposite side of angle A. And what is this side? What is this side? It is near to that angle. So the word, there is another word for near, that is adjacent. What is it? Adjacent. So hypotenuse is also adjacent to angle A. Since it has already a name, hypotenuse, we are considering only this nearer side. Okay, that side. And we are giving it a name, adjacent side. Okay, adjacent side to angle A. So BC is the opposite side to angle A and AB is the adjacent side to angle A. Is that clear to you all? What is opposite side and what is adjacent side with respect to a particular angle? And if you consider that triangle itself, but you consider angle C. So this is, again I'm naming it ABC. Consider angle C. Okay, consider angle C. So with respect to angle C, so we know that this one is 90 degree. Okay, that one is 90 degree. And with respect to angle C, what can you say about the side AB? What can you say about the side AB? This one is hypotenuse. This is clearly hypotenuse. It is the longest side of the right angle triangle and it is nothing but hypotenuse of the triangle. Okay, now we have to relate the angle C with respect to the other side. So this is the opposite side, isn't it? Opposite side to angle C, isn't it? AB is the opposite side to angle C. So what can you say about BC? What can you say about BC? Is that side adjacent to angle C? Check whether that side is near to angle C. Isn't that near? This is near, right? So this is called as adjacent side. Adjacent side to angle C. So AB with respect to C is the opposite side and BC with respect to angle C is the adjacent side. So you have to understand that with respect to the angle that we are taking, the opposite and adjacent side changes. Okay, is that clear to you all? What is opposite side and what is adjacent side? Is that clear? Please type in comment box if it is clear to you all. What is meant by adjacent side and what is meant by opposite side. Okay, so we are moving on to the next one. That is, now we are going to define trigonometric ratios. So you have already learned the concept ratios. Now we are going to learn trigonometric ratios. It is nothing but we are connecting the ratio, we are finding the ratios of the sides of this right angle triangle. That's it. And we name it as trigonometric ratio. Okay, so we'll consider a right angle triangle. Consider triangle ABC. This is angle A, this is 90 degree, and this one is angle C. Okay. So, we know I'm writing this. This is the adjacent side, right? AB is the adjacent side. And what about BC? With respect to angle A, BC is the opposite side, right? And what about AC? AC is the hypotenuse. AC is the hypotenuse. Okay, with respect to angle A, this is the opposite side. With respect to angle A, this one is the adjacent side. That's it. Okay, now we are going to define trigonometric ratios. Okay, so first of all, I'm considering, that is, I'm going to relate the sides of a triangle. Okay, we are finding some relation to the sides of the triangle. That is, first of all, I'm considering BC by AC. Okay, I'm considering BC by AC. What is BC with respect to angle A? What is BC with respect to angle A? It is nothing but opposite side. Opposite side to angle A. Isn't it? Opposite side to angle A divided by, what is AC? AC is the hypotenuse of the triangle, right? So AC is the hypotenuse. So with respect to angle A, BC is the opposite side and AC is the hypotenuse. Is that clear to you all? And this one is called as sine of angle A. What it is called? Sine of angle A. Okay, so sine of angle A is nothing but opposite side by hypotenuse of a right angle triangle. What is sine of angle A? Opposite side by hypotenuse. And what is the sine? The sine is called as the trigonometric ratio. One of the trigonometric ratio. We are going to define 6 trigonometric ratio. So sine means it is just one among those 6 trigonometric ratio. So what is sine? Sine is nothing but opposite side by hypotenuse. Is that clear to you all? Now we are going to define another ratio. Okay, another ratio, that is, I am going to take another two lines, another two sides of the triangle. That is, here I took the opposite side and the hypotenuse. Now I am going to take the adjacent side and hypotenuse. That is, from the figure, going to take AB by AC. So AB is the adjacent side of angle A, right? AB is the adjacent side, right? Adjacent side of angle A. And what is AC? AC is again hypotenuse. AC is nothing but hypotenuse of the triangle. Okay. So AB by AC is adjacent side by hypotenuse. And this one is called as cosine of angle A. This ratio, this trigonometric ratio is called as cosine of angle A. So here what we are doing is that we are connecting angle. So what are we doing here? We are connecting angle. Okay, we are connecting angle with the sides of the triangle. We are connecting angle with the sides of the triangle. This is called as trigonometric ratio. Whenever we connect angles with the sides of a triangle, the ratio that is obtained is called as trigonometric ratio, and we are giving name to all these ratios. Okay, that's only what we are doing here. We are connecting the sides with angle and we are giving it a name. Okay, so if I connect opposite side and hypotenuse, that is known as the sine of angle A. If it is adjacent side by hypotenuse, it is known as the cosine of angle A. Okay, is that clear to you all? Now we are going to define another ratio. Okay, we are going to define another ratio. So here I have took opposite side and hypotenuse. First one, I took opposite side and hypotenuse. And next I related the sides adjacent side and hypotenuse. Right. Next case, adjacent side and hypotenuse. It was nothing but cosine of angle A. Now is there any other sides that we have to relate? Isn't it? There is two sides. Right. Opposite side and adjacent side. So we can define another ratio with that. We are going to define another ratio. Okay. So we need a triangle here. ABC. And this is the right angle. And this, with respect to angle A, we are defining the ratio. So I am marking that angle. Okay. Now we are going to consider the two sides that we have not considered in the first and second cases. That is, this is the opposite side and this one is the adjacent side. Okay, opposite side and adjacent side. This one is the hypotenuse. Okay, so I'm going to take opposite by adjacent, BC by AB. That is opposite side of angle A, opposite side of angle A divided by adjacent side of angle A. Adjacent side of angle A. Opposite side by adjacent side. That is equal to tan of tangent of, it is known as tangent of angle A. So opposite side by adjacent side, that is nothing but tangent of angle A. Okay, is that clear to you? Now we are going to consider the reciprocal of all these things. So we have defined sine of angle A, we have defined cosine of angle A, and now we have defined tangent of angle A. Okay, now we are going to consider the reciprocal of all these things. That is, we are just reversing all those. Okay, first of all, if you reverse sine, what will happen? I have written here. Okay, so can you see this? Sine of angle A is opposite side by hypotenuse. So what if we consider hypotenuse by opposite side? That is another ratio, right? If we consider hypotenuse by opposite side, we'll get another ratio. So it is nothing but, it is called as cosec. What it is called? Cosec of angle A. Cosec of angle A. That is hypotenuse by opposite side. It is called as cosec of angle A. Now again, in the second case, we defined cosine of angle A, right? It was adjacent by hypotenuse. If I reverse it, what will happen? It will become hypotenuse by adjacent. That is known as sec of angle A. Sec of angle A. What was that? Hypotenuse by adjacent. Now, in this page itself, we have defined tangent of angle A. If I take the reciprocal of that, what will happen? Opposite side by adjacent will become adjacent by opposite. Right? Adjacent by opposite. That is nothing but cot of angle A. Cotangent. Okay? Cotangent of angle A. Adjacent by opposite is nothing but cotangent of angle A. Okay? So, we are just concluding everything. Okay? So we have defined sine of angle A. Okay, sine of angle A. So I'll show you a slide connecting the sides. Okay, this is better. So sine of angle A is side opposite to angle A by hypotenuse, right? Opposite by hypotenuse. Cosine is adjacent by hypotenuse. Tangent is opposite by adjacent. And what about cosecant? Cosecant was just reverse of sine, right? Reverse of sine means reciprocal of sine. So we can write this as 1 by sine also, right? We are taking the reciprocal. That means it was sine. We are considering the reciprocal of sine. So we can write this as 1 by sine also. So that is hypotenuse by opposite. Okay. Secant means nothing but reciprocal of cosine. So that is nothing but hypotenuse by adjacent side. Just reverse all these things. You need only study sine, cosine and tangent and understand that the cosecant is the reverse reciprocal of sine. Secant is the reciprocal of cosine and cotangent is the reciprocal of tangent. Okay, only need to study these three. Just understand the relation between all the other three. That is, sine is pairing with cosecant. SC. Okay, sine is pairing with cosecant. Cosine is pairing with secant. Here also you can see C and S. I'm just connecting it to memorize. For it will be easy for you to memorize. Okay. Sine, the reciprocal is cosecant. Cosine, the reciprocal is secant. And the pair of tangent. Tangent is cotangent. What is it? Cotangent. Okay. Sine and cosec are a pair. Cosine and secant are a pair. Tangent and cotangent are a pair. Okay, what is the relation between all these? Cosecant is a reciprocal of sine, or we can say that sine is a reciprocal of cosecant. Cosine is a reciprocal of secant, or secant is a reciprocal of cosine, and similarly with tangent also. Okay, so in maths we all We need simplify words, right? So for sine, cosecant, cosine, secant, tangent, etc., we have abbreviations. Okay, we have abbreviations. That is, we use sin A, cos A, tan A, cosec A, sec A, and cot A. That is, we are shorting it. Okay, sine, we are writing it as sine only. And then cosine can be written as cos only. Then tangent can be written as tan. Cosecant can be written as cosec. Okay, and secant can be written as sec. So these are the abbreviations of the trigonometric ratios. Okay, is that clear to you all? And we know these cosec, sec and cot A are the reciprocals of sine, cos and tan. Okay. I hope this much is clear to you all. Now we have to study a relation between tan, sine and cos. Okay. Tan, sine and cos. So again, if you consider a triangle, a right triangle, ABC, and consider angle A. Okay, so I'm taking this tan A. Tan A is nothing but opposite by adjacent, right? So BC by, I'm considering BC by AB. BC by AB. And I'm dividing this BC and AB with AC. Okay, that is BC, I'm dividing it with AC. Similarly, AB also I'm dividing it with AC. So what you will get, BC by AC means it is nothing but opposite by hypotenuse. AC is the hypotenuse, right? AC means hypotenuse. So BC is opposite side. Opposite by hypotenuse. What is the trigonometric ratio? It is nothing but sine A. Okay. Sine of angle A is shortened and written as sine A. Okay. Sine of angle A is shortened and written as sine A. BC by AC is nothing but sine A. Is that clear to you all? Divided by, what is AB by AC? AB is the adjacent side. AB is the adjacent side. AC is the hypotenuse. So adjacent by hypotenuse is nothing but cos A. So sin A by cos A. So we can define tan A is equal to nothing but sin A by cos A. Okay. Tan A is nothing but sin A by cos A. And we know that cot A is a reciprocal of tan, right? Cot is a reciprocal of tan. So we can just reverse this thing. Sin A by cos A can be reversed. That is cos A by sin A. Cos A by sin A is nothing but cot A. Now have you understood what is trigonometry ratio and the relation between tan, sin and cos? I hope everybody has understood this concept. Okay. And this one I have already mentioned to you. That is sin A, it is just the abbreviation. It is a short form of sine of angle A. Sin A separate, sine and separate A has no meaning. This one separately doesn't have any meaning. Sin A, it is nothing but it is a short form of sine of angle A. Similarly, cos A is the short form of cosine of angle A. It is not the product of sine and A. Okay, that is wrong. It is not the product of sine and A. It is just an abbreviation form for the sine of angle A. Okay. Now, the values of the trigonometry ratios of an angle do not vary with the length of the sides of the triangle if the angle remains the same. What is it? Consider two right triangles like this. Okay. One is small and the other is big. I am giving it ABC. This one, let it be PQR. Let it be PQR. This one is 90 degree. This one is also 90 degree. This one, let it be 60 degree. This is also 60 degree. And this is 30 degree. This is 30 degree. Here you can see that in these two triangles, all the angles are equal, right? All the angles of these two triangles are equal. Even though the sides are not equal, all the angles are equal. So what can you say about triangle ABC and triangle PQR? They are similar triangles. Since both in the both triangles all the angles are equal, we can say that those two are similar triangles. And in similar triangles, the corresponding sides are equal, right? The corresponding sides, sorry, equal sides will be in a proportion, right? So using that, we can say that here BC by AC will be equal to QR by PR. Okay, it is just simply I can say that if sine 60, if sine 60, sine 60 is nothing but 1 by 2. If sine 60 is 1 by 2 in this triangle, sine 60 is 1 by 2 in this triangle also, in the second triangle also. That is, the trigonometric ratios of a specific angle will not change its value with respect to the sides of the triangle. Here you can see that the sides are not equal, but the trigonometric ratios of fixed angles are always fixed. That's what I mentioned in that slide. The values of trigonometric ratios of angle do not vary with the length of the sides of the triangle if say. Okay. Now, one more point is that after that we'll start doing the problems. Okay, we'll start doing the problem. So that is, since the hypotenuse is the longest side in a right triangle, the value of sine A or cos A is always less than 1 or in particular equal to 1. So what is it? We know that in a right triangle, hypotenuse is always the longer side. Isn't it? Hypotenuse should be the longer side. It will always be the longer side. So we know that sine A is nothing but opposite by hypotenuse, right? Sine A is nothing but opposite side by hypotenuse. So here you can see that since hypotenuse is the longer side, in the denominator the value will always be larger, right? For example, if you consider 3 by 4, okay, 4 is greater than 3 because 4 is a hypotenuse. So it will always be, the denominator will always be greater than the numerator. So this value will always be less than 1. 3 by 4 is nothing but 0.75, right? It is always less than 1. So we can say that the value of sine A and cos A will always be less than 1. What is the reason? In the denominator, you can see in cos A also, you can see that the denominator is a hypotenuse, and this hypotenuse, since hypotenuse is the longest side, the numerator will always be smaller than the denominator. If the numerator is smaller, we can say that that particular fraction will be less than 1, right? That particular fraction will be less than 1. So we can say that sine A and cos A will always be less than 1. Okay, now we are going to do problems. You are given tan A is equal to 4 by 3. Tan A is equal to 4 by 3. You have to find out the trigonometric ratio sin A and cos A. You have to find out the trigonometric ratios sin A and cos A. Okay, tan A is 4 by 3. You have to find out sin A and cos A. So for that, I am considering a right angle triangle. So this is our right angle triangle. It is ABC. I'm giving it a name, ABC. Okay. Since tan A is given, A should be our acute angle. That is the angle that different from 90 degree. Okay. So tan A is equal to 4 by 3. What does that mean? What does that mean? We know tan A connects the opposite side and adjacent side, right? Tan A is nothing but opposite side by adjacent side, right? Tan A is opposite side by adjacent side. Okay, so which is the opposite side here? Which is the opposite side? 4, right? So angle opposite to, sorry, side opposite to angle A is 4. And which is the adjacent side? Which is the adjacent side? It is 3. It is given in the question. Okay, so it is 3. We got the opposite side and we got the adjacent side. Now we have to find out sin A and cos A. What is sin A? Sin A is nothing but opposite side by hypotenuse. Right? Sin A is opposite side by hypotenuse. So, do we know the value of hypotenuse here? We don't know the value of hypotenuse. So, how will you find out the value of hypotenuse? For that, hypotenuse square is equal to, we know it is by using Pythagoras theorem, AB square plus BC square. Right? AC square is equal to AB square plus BC square. Right? So, AC square is equal to AB is 3 square plus 4 square. So what is AC square? AC square is equal to 9 plus 16. That is equal to 25. We need the length of AC. So AC is equal to root 25. That is equal to 5. AC is equal to root 25. That is equal to 5. So we got the length of AC. Now can you find out what is sin A? Can you find out sin A? We have got AC as 5. So sin A is opposite by hypotenuse, right? Opposite side is 4 by hypotenuse. Now we have obtained. It is nothing but 4 by 5. Now what about cos A? Cos A is equal to, how will you find out cos A? It is adjacent by hypotenuse. It is adjacent by hypotenuse. What is the adjacent side? Adjacent side is 3. So it is nothing but 3 by 5. 5 is the hypotenuse. Adjacent by hypotenuse, that is equal to 3 by 5. Is that clear to you all? Now moving on to the exercise questions. First one, in triangle ABC, in triangle ABC, that is right angled at B, AB is equal to 24 centimeter, BC is equal to 7 centimeter. Determine sin A, cos A, and second one is sin C, cos C. Okay, so that is the question. So we have to draw, first of all, we have to draw a right angle triangle. And they have given that it is right angled at B. That is, at B it forms a right angle. So 90-degree angle should be marked in B. So here you can give it as A and this one as C. Okay. AB is equal to 24 centimeter. AB is equal to 24 centimeter and BC is equal to 7 centimeter. We have to find out sin A and cos A. First of all, sin A and cos A. So in order to find sin A, first of all, we have to define that ratio, right? Sin A is equal to opposite side by hypotenuse. Isn't it? Sin A is opposite side by hypotenuse. So here we know this is the angle A. I'm marking angle A also. So this is the opposite side of angle A. But do we know the hypotenuse here? We don't know the hypotenuse AC. So first we have to find out AC by using Pythagoras theorem. Okay, then only we can find the value for sin A. Okay, for that we have to find out AC. By using Pythagoras theorem, we can write this as AC square is equal to AB square plus BC square. Right? AB square is 7. AB is 24. AB is 24, right? 24 square plus BC is 7. So 7 square. AB square plus BC square, that is 24 square plus 7 square. That is equal to AC square is equal to, that is 24 square is 576 and plus 49, right? 576 plus 49. So you will get the value as 625. AC square is equal to 625. So what is the value of AC? AC is nothing but root 625. That is equal to 25. AC is equal to root of 625, which is 25. Now we have obtained the value of AC. It is nothing but 25 centimeter. Now can you find out sine A? Can you find out sine A? What is sine A? Opposite side by hypotenuse. Opposite side is 7 and hypotenuse is 25. So 7 by 25. Is that clear to you all? Sine A is nothing but 7 by 25. Okay. Now we have to find out cos A. What we have to find out? We have to find out cos A. Cos A is equal to adjacent by hypotenuse, right? Adjacent side by hypotenuse. Cos A is nothing but adjacent side by hypotenuse. So what is adjacent side here with respect to angle A? This is angle A, okay? With respect to angle A, which is the adjacent side? This one is the adjacent side, right? So what is the measurement of adjacent side? It is 24 by, what is hypotenuse? We have already obtained it as 25, right? So this one is 24 and this one is 25. So cos A is nothing but 24 by 25. Okay, now we have to find out sine C and cos C. We have to find out sine C and cos C. Sine C, again, it is opposite by hypotenuse. Okay, opposite by hypotenuse, but the angle is different, right? With respect to angle C, which is the opposite side, with respect to angle C, it is AB, right? Opposite side is AB. What is AB? 24. 24 divided by hypotenuse is 25 itself. And with respect to angle C, we have to find out cos C. So with respect to angle C, which is the adjacent side is BC. Cos C is nothing but adjacent side by hypotenuse, and here adjacent side with respect to angle C is BC. That is 7 centimeter divided by what is the hypotenuse? It is 25. So sine C is 24 by 25 and cos C is 7 by 25. Okay. Hope it is clear to you all. Now we are moving on to the second question. In figure 8.13, find tan P minus cota. We have to find out the value of tan P minus cota. For that, we have to first obtain what is tan P and what is cot R. Right. For that, first we have to find out tan P. Tan P is nothing but, what is tan P? Tan P is opposite side by adjacent side. Tan P is opposite side by adjacent side. Right. So, this is the angle P. Which is the side opposite to angle P? Which is the side opposite to angle P? It is QR, right? Angle P. The opposite side to angle P is QR. And what is the adjacent side? Adjacent side is PQ. So we know the measurement of PQ, but we don't know QR. So first we have to find out the measurement of QR. For that we have to apply Pythagoras theorem, right? So PQ square plus QR square is equal to PR square. PQ square plus QR square is equal to PR square, right? Okay. Now, PQ square we know it is 12 square plus QR square we don't know. We have to find it out. And PR is given as 13. So it is 13 square. So QR square is equal to 13 square minus 12 square. Isn't it? So that is equal to 169 minus 144. 169 minus 144. So, am I audible to you? So this is equal to 25 and QR square is 25, which implies what is the value of QR? What is the value of QR? That is equal to root 25. So the value is 5. Okay, so we obtained the value of QR. Now we have all the sides, right? PQ is 12 and PR is 13 and QR is now obtained as 5. Now can you find out what is tan P? It is easy, right? So what is tan P? Tan P is equal to opposite by adjacent. Opposite is now we have obtained it as 5. What is the adjacent side? Adjacent side is 12 centimeter, 5 by 12. Okay. Now what we have to find out? We have to find out cot R. So for that, consider angle R. Consider angle R. Okay. So if you don't know what is the ratio of cot R, you consider its reciprocal. What is the reciprocal of cot? Reciprocal of cot, it is nothing but tan, right? So you find out tan R. Okay, you find out tan R. What is tan R? Tan R, you know, opposite by hypotenuse, right? So opposite side, sorry, opposite by adjacent. So opposite of uh, so tan R, opposite of angle R is 12, 12, right? Opposite of angle R is 12. And what is the adjacent side of angle R? It is 5. So tan R is equal to 12 by 5. But we need cot R, right? We need cot R. So consider its reciprocal. Just reverse the value of tan R. So we'll get the value for cot R. So cot R is equal to the reciprocal of this value. What is the reciprocal? 5 by 12. Just reverse that fraction. 12 by 5 will become 5 by 12. Just reverse the ratio. Okay, so we obtained the value of cot R. Now what we have to find out? We have to find out tan P minus cot R. Tan P minus cot R. Tan P is 5 by 12. Right. Tan P is 5 by 12. And now cot R is also 5 by 12. So 5 by 12 minus 5 by 12 is equal to 0. Okay. So we obtained the value of tan P minus cot R. It is nothing but 0. Okay, so moving on to the third question. If sin A is equal to 3 by 4, calculate cos A and tan A. Okay, so this you can do it as a homework. Okay, since we have done some problems related to this, you can do. I think you can do this as a homework. Okay, so we are moving on to the fourth question. Given 15 cot A is equal to 8, you have to find sin A and sec A. So it is given 15 cot A is 8, but we need only the the ratio of the trigonometric ratio, right? So we need only cot A, the value of cot A. That is cot A is equal to 8 by 50. Cot A is equal to 8 by 50. We have to find out sin A and sec A. We have to find out sin A and sec A. Okay. So for that we need a right triangle, right? So since cot A is 8 by 15, what can you say about tan A? What can you say about tan A? Tan A is the reciprocal of cot, right? So we can just reverse the ratio. So 8 by 15 will become 15 by 8. Tan A is equal to 15 by 8. Okay. So here we are discussing about angle A. So let this be B and this one is A, this be C. Okay. So this we know that it is nothing but opposite by adjacent. Tan is nothing but opposite by adjacent. So here the side opposite to angle A. The side opposite to angle A is 15. Side opposite to angle A is 15. What is the side opposite to, what is the adjacent side to angle A? Adjacent side, it is 8, right? So adjacent side is 8. So if you want to find out sin A, we need the hypotenuse. So again, we need to apply Pythagoras theorem in order to find out AC, the value of AC. So AC square is equal to AB square plus BC square, right? So that is equal to, it will be AB means 8, right? 8 square plus 15 square. That is 8 square plus 15 square. It is 225, right? 225. And what is, sorry, 8 square is 64. So 64 plus 225. Okay. So AC square is equal to 64 plus 225. That is equal to 289. Okay. So AC is equal to root of 289. Root of 289 is nothing but 70. Okay. AC is equal to root of 289. That is equal to 17. So we obtained the value of AC. AC is nothing but 17. Now can you find out the value of sin A? Can you find out the value of sin A? What is the ratio sin A? How can you define sine of angle A? Sin A is nothing but opposite by hypotenuse. It is nothing but opposite by hypotenuse. So what is the opposite of angle A? Let's see what is the opposite side. 15, right? What is hypotenuse? 17. So what is this ratio? 15 by 17. What is sin A? 15 by 17. Now what we have to find out? We have to find out CK. So CK, if you don't know the ratio of CA itself, but if you know the relation between sec and cos, you can easily find it. Okay, sec A, if you are asked to find out sec A, think about its reciprocal cos A. Okay, reciprocal of sec is cos, right? Cos A is nothing but, cos A is, we know it is adjacent by hypotenuse. Okay, cos A is nothing but adjacent by hypotenuse. So here, which is the side adjacent to angle A? It is 8. And what is the hypotenuse? It is 17. So 8 by 17. Isn't it? Cos A is 8 by 17, but we are asked to find out CK. We are asked to find out CK. So CK is just the reciprocal of this value, right? 8 by 17. Just reverse it. It's equal to 17 by 8. So we have found out the value of CK as well as sin A. Is that clear to you? So, given sec theta is equal to 13 by 12, we have to calculate all other trigonometric ratios. Okay, sec theta is given as 13 by 12. So, again, we need a triangle. We need a right angle triangle. Okay. So they are given as sec theta is 13 by 12. It is nothing but they are given a specific name to the angle. You can, here it is given as theta. You can take it as x or anything else. Here it is given as theta. So we'll take it in terms of theta itself. So first of all, we need a right angle triangle. Let it be ABC. Okay, let one acute angle be theta. What is acute angle? Acute angle means angles which are less than 90 degree. Since this is 90 degree, the both these angles will be less than 90. So both the angles will be acute angles. So any, you can consider any of the angle. You can take B or C as theta. So here I am taking B as theta. Okay, so they are given sec theta is equal to 13 by 12. So from this, can you find out the value of cos theta? You are given sec theta. Can you find out cos theta? Sec and cos are pair, right? Sec and cos are pairs. What is the relation between sec and cos? They are reciprocals of each other. So the sec theta is 13 by 12 means cos theta is nothing but 12 by 13. Cos theta is nothing but 12 by 13. So what is cos theta? What is cos of an angle? Cos means nothing but adjacent side by hypotenuse. Isn't it? Adjacent side by hypotenuse is cos theta. So here if you consider angle theta, what is the adjacent side with respect to theta? With respect to theta, which is the adjacent side? AB is the adjacent side. Isn't it? AB is the adjacent side. So what is the value here? Adjacent side is 12. From the question we have got that adjacent side is 12. What is the hypotenuse? From equating this we get hypotenuse is equal to 13. So what is the value of BC? It is nothing but 13. Now what you have to do, if you have to find out all the trigonometric ratio, we definitely need this one also, because it is the side opposite to angle theta. So we need to find that value. So again, by using Pythagoras theorem, find out the value of AC. How will you find out the value of AC? AC square is nothing but we have to subtract it from the hypotenuse square, right? 13 square minus 12 square. I'm skipping some step because it is repeating again and again. So till waste our time. Okay. So AC square is equal to 13 square minus 12 square. That is equal to 169 minus 144. The value is 25. So what is AC? What is AC? AC is equal to root 25. That is equal to 5. So we have obtained the value of AC. Now can you find out all the other trigonometric ratios? All the other trigonometric ratios. First of all, we'll find out sin A. Okay. We'll find out sin A. Sorry, here it is not angle A. Here they have given a name for angle. So it is sin theta. So first we are going to find out sin theta. So what is sin theta? Sin theta is nothing but opposite by hypotenuse. What is it? Opposite by hypotenuse. Sin theta is equal to opposite by hypotenuse. So what is opposite side here? It is 5. And what is the hypotenuse here? It is 13. So 5 by 30. Okay. Now, uh, just consider its reciprocal. What is the reciprocal of sine? Cosec, right? Sine and cosec are pairs. So cosec theta. Cosec theta. You don't need to know the exact definition like this. Okay, you just need to reverse the value of sine theta. Sine theta is 5 by 13. Then what is the value of cosec theta? Since it is a reciprocal, just reverse that ratio. 5 by 13 will become 13 by 5. That is the value of cosec theta. Now what we have to find out? We have to find out tan theta, right? Sec theta and cos theta we have already obtained. So we have to find out the value of tan theta. Tan theta. What is tan theta? Tan theta is nothing but opposite by adjacent. Okay, tan theta is equal to opposite by adjacent. What is the opposite side here? Opposite side is 5, and what is adjacent side here? Adjacent side is 12. So it is nothing but 5 by 12. So we obtained the value of tan theta. Now what is cot theta? Cot theta is just reciprocal of tan theta. Cot theta is nothing but 12 by 5. Okay, cot theta is equal to 12 by 5. So we have calculated all the 6 trigonometric ratio. Okay. So is that clear to you? So we can do this problem also. If angle A and angle B are acute angles such that cos A equal to cos B, then show that angle A equal to angle B. First of all, consider a right angle triangle. Let this be ABC. Okay. So they are given as angle A and angle B. Angle A and angle B are acute. And they have also given a relation that cos A is equal to cos B. Cos of angle A is equal to cos of angle B. So what is cos A? According to this triangle, what is cos A? With respect to angle A, you have to define cos. What is cos? Adjacent side by hypotenuse, right? Adjacent side of angle A is AC. So it is AC by hypotenuse here is AB. AC by AB. All right. And what is cos B? With respect to B, adjacent side is BC. So it is BC by AB. This BC by AB. And according to the question, cos A is equal to cos B, which means AC by AB is equal to BC by AB. Since the denominators are same for both, right? The denominators are same. So we can write AC is equal to BC, right? AC is equal to BC. AC equal to BC means these two sides are equal. In triangle ABC, these two sides are equal. If those two sides are equal, what is that triangle called? It is an isosceles right angle triangle, isn't it? It is an isosceles triangle. Isosceles triangle, we know the base angles formed by equal sides will be equal, isn't it? In an isosceles triangle, base angle will be equal. So we can say that angle A is equal to angle B. Okay. AC equal to BC. Therefore, triangle ABC is isosceles. Okay, isosceles. Since it is an isosceles triangle, the base angles will be equal. So we can conclude that angle A is equal to angle B. Okay. Now we have a few more problems in this session. We'll continue it in the next session. Okay. I hope this much is clear to you all. And you have some problems in the example section. It is already solved in your textbook. You should try it as a homework. Okay. Is that clear to you all? Was this session useful to you? Are you understanding trigonometry? Can anyone reply? Are you getting what I'm trying to say? Okay, then thank you. We can continue this chapter in the next session. Okay, bye. Thank you.